Hi. So measurement, different topic now. And so with measurement and figuring out areas and all that, I like having a tangible thing that I can work with. Okay, so here I have a right angle right over there. That means 90 degrees. What kind of triangle is this? What kind of triangle? And rather than actually giving me mathematical proper term, I want you to think about what kind of attributes that you can find with this triangle. I gave you one thing, okay? This angle, this is 90 degrees. What about the other two angles? How can you figure out what kind of angles that these 2 points offer? Well, how would you figure that out? I want you to think about it. You can, I guess, use a protractor, but I don't have one at home. What would you do? What do I need to know? Well, if I fold it in half, can you not actually give you proof that these two are the same angles? If I fold it in half, see, they match up. This is my proof. I can give you proof in my hands. So what if I have these two of these things that is exactly of the same size? How many shapes can you make? And if I have more than two, how many shapes can you make? That's something you could work it out. Can I make a square? How would you know that it's a square? What is the definition of a square? How can you prove it? What else can I do? What kind of shape is this? What else can I do? Can I do something like this? I'm sure there are a lot more that I can make. But if all you need are a piece of paper and some pens and some scissors, and you can play around with some area ideas. And I am someone who needs a proof. I need a proof as to, okay, you can't just tell me this is of the same. I need to know. How can I prove that? I need an answer. So I'm sure you all have learned already that if you multiply length by width, you get an area of a rectangle or square. How can I prove that though? How would I know that is true? So if you want some kind of proof, this is what you could do. Okay. Hopefully this shows. Okay. Ish, I guess. Oh, not quite square. Okay, not quite straight, but alright. Having a clumsy moment right over there. Okay, so if let's suppose that I have squares that is 1 centimeter by 1 centimeter, how can I use this information to figure out how to figure out an area of a triangle or a square or parallelogram? I almost bit my tongue saying that. Or trapezoid. You could create many different shapes and figure out, okay, is this really true? You know what? This formula, it's supposed to work for example, the formula for a triangle. Length multiplied by width divided by 2. That's supposed to work for every single kind of triangle. Is that even true? And same with the parallelogram. It doesn't matter what angles these two parallel lines are, it's supposed to work. Is that true? So you want to figure that out, you can make as many trapezoids, parallelograms, squares, and triangles. You could try to figure out, is this true? Is there a way that I can prove it? So the way that I could prove this one, for example, is I'm going to count how many squares that I have. For example, the square one is the easy one. I'm going to count 1, 2, 3, 4, right? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Seems legit. And I know that they are 1, 2, 3, 4 squares right over there. And I have 4 by 4, right? And it is like, if I think of it, I can think of it as, I have 4 right here. 1, 2, 3, 4. I have 4 here. I have 1, 2, 3, 4 here. I have 1, 2, 3, 4 here. So I'm adding 4 because there's 1, 2, 3, 4, right? So I'm adding 4 times. And I've been saying repeated addition is multiplication. So I know that when I actually add 4 times, that means 4 multiplied by 4. I know how many squares that I have. 4 by 4. Hey, that is actually length multiplied by width, because the length and width in this case, both of that is 4. So seems like it works. I'm happy with this as my proof. What about a triangle? Can you do the same? What about the fact that it's cut in half? Well, what you could do is you can examine this a little. There are many ways to figure this out, but I could also take a quick look at my little square right over here. What do you notice? Well, I notice that it's cut in half. That means I can think, if I wanted to know the area of this side of the triangle, I can count this one as 0.5 because I don't quite have 1. And if I see that, I have 0.5, I have here, I have 0.5, I have another 0.5 over here, I have another 0.5 over here, right? So I have 1, full 1, 2, 3, 4, 5, 6, and I have 4 halves. Now I know that if I move this half to here, I have a full square. If I move this little triangle to this side, I have a full square. So that means I have with this one and this one, I have 1 full one. And with this one and this one, I have a full square. So that means I have 8. I'm okay with that. Or you could think that, you know what? With this square, I had 16. And I'm cutting the 16 in exactly half. That means 16 divided by 2 must be 8. So you could think of it that way, or you could count in this way as well. That's one way. So what about this one? When I actually take a look at this little square right over here, this is not cut in half. I'm looking at this little one right over here. If I'm looking at this, it's not cut in half properly. Okay, so that I can't use the same tactic that I use, strategy that I use right over here. This is not cut in half properly. What do you do? Well, this is where you get to use your brain. So, you know what? I'm going to count the full ones first, so because I can get that out of my way. So like I have a fewer things to worry about. So I have 1, 2, 3, and 4, and 5, and 6, and 7, and 8. I'm going to stop right over here because I know that there are more full ones. But I could look at it this way as well. If I actually take a look at this right over here, do you see that this line right over here is cutting 1, 2, 3, 4, 5, 6, 7, 8. So then I have 8 squares within this rectangle. It's a 2x4 rectangle. And look, this is cut exactly in the middle. If you want to prove that it's exactly the same, you could cut it and you could superimpose both of the triangles on top of each other and see is it exactly of the same size. But it's cut in half. So can I not say that it is almost the same as I have 1, 2, 3, 4 full circles instead of having, because I have 1, 2, 3, 4, 5, 6, 7, 8 for, not circles, what I'm saying. 1, 2, 3, 4, 5, 6, 7, 8 squares, but because this line is cutting this shape into exactly the half, in half exactly, that means it's exactly the same as having 4 full squares. So I could just change the shape to having that, right? So that's, you can now go 8, 9, 10, 11, 12. That's one way to count. Or you could also look here. And think about what you notice in this smaller rectangle. So isn't this also cut in half? So isn't it exactly the same as having 1 square instead of 2? Because I have 2 squares right over here, but my line is cutting these 2 squares in half. I have 2 squares, but the 2 squares are cut in half. So it is like having 1 full square. So I could count this part, right? This side. I could count that as 9. And 10. And 11, because these are full ones. And hey, look over here, it's the same. I have 2 squares, but the 2 squares are cut in half. So 2 squares are cut in exactly halfway. So now I can count this part as 10, right? And here I said, well, if I'm looking at right over here as the whole thing is cut in half. The whole thing has 8 squares. 8 squares divided by 2, because you only need half of that, because I only want this part. So 8 divided by 2, that's 4. So I'm going to add 4 more. So that I did something funky here. 10, 9, 11, this would have been 12. So I have 13, 14, 15, and 16 squares. 16 squares in this parallelogram. So if you are sort of trying to get into the rhythm of, okay, thinking about areas and how you can prove why the formula of length multiplied by width for squares, rectangles, and parallelograms, why that works, and length multiplied by width divided by 2 for triangles, you could create a sheet like this in your notebook, or you can do that on an Excel spreadsheet or Google spreadsheet, and you can figure it out. Okay, where is it divided in half? Maybe it's not divided in half, but divided in quarters. And if you start to notice that kind of thing, things will start to make sense. So that's one way to practice thinking about areas and measurements. Okay, thank you.